Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the challenge number 7, the medium challenge called the reverse integer. And for this particular challenge, given a sign 32-bit integer x, return x with its digits reverse. If reversing x causes the value to go outside the sign 32-bit integer range, which is -2 exponent of 31 or the power of 31, and then the range above the 2 with the power of 31 and -1, then return 0. So that is the minimum, and this is the minimum range of the 32-bit integer, and this is the maximum range of the 32-bit integer, and we need to return 0. And we need to assume that the environment does not allow us to store 64-bit integers or anything below the 32-bit variant. And for this example number 1 right here, we have the input of the x, which is 1, 2, and 3, and the output should be 3, 2, and 1. Why? It's because we are reversing the 3 onto the front, 2 onto the middle, and 1 to the last one. And for the example number 2 right here, we have the input of the minus or the negative 123, and we have the output of the 321. Why the negative sign is not being removed is because this is part of the challenge that we need to preserve the negative number, but still reversing the integer and excluding the negative from the calculation. And also for the example 3 here, which is 120 or 120, but on the reverse part, which is on the 21. Why? Is because if we reverse this by using 0, 2, and 1, we will have the result of the integer 21. You might want to use a string manipulation using the array, since we are using the TypeScript right here. But for this part of the challenge, we are working with integer number, so that is considered a little bit cheating or making things much more easier by using the array and string instead of using the operating on the integer with the basic math calculation. And we are using the TypeScript as our language. If you want to use something else other than TypeScript, then go ahead. I encourage you to do so. And we have the function called the reverse right here. Takes only one parameter called the x, which is in the form data type of number, and the expected output is also in the form of number or integer. And then we have to reverse this by creating a storage to store the reverse value by creating the let property called the reverse, and we initialize this with the 0, and we need to check if the x value, since we can mutate the parameter, which is the x parameter right here, we can mutate this to be any number that we need to operate in order to get the reverse order. We can do this by using the while loop while the x is above 0. As long as x is above 0 or is not 0 at all, then we need to continue our iteration by looping on the number, doing the mathematical operation. And the first thing, we need to use the digit constant to store the digit of the number what we are trying to extract from the back of the integer x onto the output of the reverse as the output right here, from the back to the front, using the constant, and we call this digit. And we need to extract the digit from our x using the x and then the remainder operator of 10, and that way we can get the digit of every input of the x. How do we do this? Since we already declared the digit with the x divided by 10, then we need to x to be mutated along the way with the while loop until the while loop hits 0. Then the while loop will stop and we return the answer of the reverse. Don't forget to return the reverse variable from the function. And we need to, after we do the calculation of the digit, we determine the digit by using modulo of 10 or the remainder of 10. Let's say we have the value of 123, then the remainder operator using the left hand side of the left hand operand using the x, and then the right hand operand using the 10. It's like we are using the division by 10, and then we get the value of 12.3. But then since we are using the digit, then the 12.3 is going to be returned as the 3 only. Why? It's because if we use the direct division, we have the value of 12 and the remainder is 3. If we use 12 multiplied by 10, we got 120. In order to get to the 123, we need to add this by 3, so that is the difference, and the 12 is the value of the new x that we need to take note to be processed inside the while loop of the next iteration of the while loop. And that way we are comparing the 123 with the 120 and we got 3, and then 3 will be returned as the digit. So that is the way to, that is one of many ways to return this, and we got return this as the digit. But in real, if we use the division, we got the 12.3, but then in using the remainder operator we got 12, but since using the remainder operator, then we got 3 instead. 3 is being stored as the digit. And the next thing, we need to mutate the x itself by using the x equals to the x divided by 10. But then if you use this right away, divided by 10 directly, let's say we have 123 divided by 10 and we got 12.3, and the x value is going to be 12.3. But then we only need to calculate the 12 only to be calculated with the remainder operator, and we got the exact digit, which is 2 right here. We need to extract the 2 from the digit to be processed on the next iteration. How do we eliminate the floating number and then we get the proper result of our while loop operation? It is fairly simple. In order to do this, we can use the Math.trunc method, and we got only 12. You may want to use Math.floor by using the like this, or Math.floor by using x and then divided by 10. Since we got 12.3, then the Math.floor will floor this to the nearest integer, which is 12. If we use Math.ceiling, then we get 13, but that is out of context, so we only need to use the Math.trunc because it is more faster than using the Math.floor. And we can just eliminate any of the floating number, and we can just process this by using the truncation method. Process the integer instead of the floating number, and we just eliminate the 3.3 from our real calculation of the x divided by 10. And we can use this Math.trunc by wrapping this inside the parenthesis, and then in front of it we can use the Math.trunc. And then the next thing, we need to store the reverse using the digits itself, but we need to do the reverse and then times 10 and then added by the digit. And that way, since we have the value of reverse of 0, then 0 will be multiplied by 10 and we still got 0, but then plus digit we got the value of 3. That is the first iteration. On the second iteration, since we are extracting 2 as our digit will be 2, and the x will be 1, I believe, because using the Math.trunc of the 12, the 12 divided by 10 is equals to 1.2, but then we are truncating it and we got only 1 as the new value of the x already mutated inside the while loop. But then since it is parameter, then we should not worry about this being mutated or not. And we got the reverse, and we got the 2 from the reverse. Since the reverse or the existing reverse value of the 3, then we need to use 3 multiplied by 10. We got 30, and then 30 added by digit, which is 2. 30 plus 2, which is the latest digit from the middle part, and we got 32. And the last iteration on the while loop iteration, we got the digit of x equals to 1, and remainder or the modulo operator of the 10, and we still got 1 as our answer from the digit. And since digit already 1, take note that it is already 1, and the x, we need to use the Math.trunc of the 1 divided by 10. We got 0.1, and then since we truncate this, we got 0 as the new value of the x. And the while loop it's not going to stop early because we need to still complete the code operation inside the while loop scope, and we have to process the remaining part, which is the reverse right here. Reverse, which is 32 multiplied by 10, and we have the shift value of the 320, and then plus the digit. Since the digit is 1, then we need to use 1 as the new digit, and we have the value of the 321, and we can use the console.log to check what is the digit is about, and we can run this to see how the code works. And we have the correct one, which is the test case 1 right here. We have the standard output from the every iteration, the digit iteration, which is 3, 2, and 1. We have the output of the 3, 2, and 1, and the x is 1, 2, 3, so that is the reverse. But then on this part, it is a negative sign or the minus sign, but then the output is only 0, and the reverse is not being stored anything, and the expected output is supposed to be negative 321. But then why that happens is because we have the x check right here. As long as x is above 0, not below 0, or not x is not equals to 0, so that is the caveat of using the x above 0, and the negative number is not being considered as the while operation right here. But then on the case number 3 right here, it is properly executed. The first one, which is 0, second one, which is 2, and the last one, which is 1. And 0 is not being counted as the output, is because 0 as the digit right here. We have the first reverse as the 0, the first iteration, and then multiplied by 10 equals to 0, and then plus the digit, which is 0, and then we still got the reverse on the first iteration as 0 on the second iteration, and we got 2, because 0 multiplied by 10, we got 0, and added by the digit, which is 2, and we have the value of the 2 on the reverse on the second iteration, which this part. And on the last iteration, we have the value of 1, is because on the last operation of the reverse, we got 20, and then 20 added by digit, which is 1, and we got 21 as our answer. So we already covered the basic things of reversing the number. Then we need to handle the negative part by using the x. As long as x is not equals to 0, then we can handle both negative and positive numbers, and we can use the run again test to see if it works on the case number 2. And we have the standard output of the -3, which is correct from the minus 123, and remainder by 10. We got the -3 as our remainder, and we are inserting the -3. 0 plus -3, we got the reverse value of the -3 on the first iteration. On the second iteration, which is -30 plus -2, we got -32, and then on the last iteration, which is 1, we got the -320, and then plus the minus again, minus digit, -1. Since it is -1, then it will be -321 or negative 321. And let's submit this code to see if it works. And we have the wrong answer of the output right here, and this part of the output is supposed to be expected as the 0, is because this output right here is surpassing the limit of the 32-bit of integer. If you still remember about the first check right here of the 32-bit positive integer, this is the limit, this part is the limit. Then we need to declare the limit, and we can add a check after the while loop to check if it is surpassing the limit, positive limit, and both positive and negative limit. If it is, then we need to return 0. Bless me. So I'm sorry about this. Okay, so the next one, we need to declare our constant called the minimum. We need to declare the minimum value of the -2 with the power of the 31, or the exponent of the 31. How do we use this? We can use we already used the math truncation. Let me show about the math truncation. Let's refresh the page. About truncation, let me explain this shortly. And the math truncation static method, it returns the integer part of a number by removing any fractional digits. So by eliminating all of the floating number from our integer, so that is the main use of the math truncation. What if we happen to have minus 100 and then comma 567, and we got the value of just 100 as the integer number, and the floating number of 567 is not being recorded as the answer of the math truncation method. So what about the exponentation? And we have the exponent right here. We can use the double asterisk operator as the power. The left hand operand is the 3 and the right hand operand, which is 4, and that is the same thing as using the 3 with the power of 4. That is the exponent number. And this one, which is the 10 with the power of -2, and it is the same thing as the 10 with the power, denoted by the caret sign as the usual programming language or mathematical operation. If we don't have the superscript, then we can use the -2 as the power. And if we happen to run this, we have the 81. But let's say about the console.log, we need to declare the highest one of the integer 32 or the 32-bit integer, the maximum value of that. We can use the 2 with the power of the 31 and then -1. 2 with the power of the 31 and then -1. We don't have to worry about 31 is being recorded as the 30 and then with the power of the 2 with the power of the 30 is because we are following the PEMDAS rule, which is the E, which is the exponent first, and then the D, which is not D but the S or the subtraction. The subtraction takes the letter priority after the exponentation. If we run this, we have the maximum integer of the 32-bit integer. What about the negative integer part? We can use the 2 with the power of the 31, but then in front of this operation we need to add negative number, and we can wrap the 2 with the power of the 31 inside of the parenthesis to prevent the negative sign from being added or removed. If we happen to run this, we have the -21474 and so on and so forth. Let's say if we use the -2 with the power of the 31 without wrapping them first, and the result will varies, and this one is correct. But then if we use the exponent of 32 or the power of the 32, then we got the positive number. And if we use the 33, we got the negative number. If we use the 34, we got the positive number. So that is confusing for JavaScript to solve, and we have to get around this by using the 2 with the power of the 31 but wrap first, and then after that we need to assign the negative number in front of it. And let's use the minimum, declare the -2 with the power of the 31, and we declare the enum of the max enum variable because we are using the all uppercases on the variable name. We can use the 2 with the power of the 31 and then -1, and we can add the check after that using the if else check. If the reverse is lower than the minimum value or the reverse is maximum than the allowed 32-bit integer. If it is, then we need to return 0. If it's not, then we need to return the reverse as it is. So let's run the code again to see if it works. And we got the lowest runtime possible of the 96 millisecond is because we are addressing the console.log as our extra processing time. Let's run this again to see if it works. And we have the value of the 52. So that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section. Or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Let me point about something that we are using the TypeScript or JavaScript, and it's still usual time about the runtime of the 52 millisecond. If you want to use something else that faster than 52 millisecond, around this 52 or the 60 milliseconds, then you can use another language, for example Rust or the C++. Okay, so that is a little information for you. Thank you for watching the video. I have a great day and I will see you in the next video. Goodbye.